guys! Today we're going to go over balancing chemical equations and how to do that. Alright, the first thing you need to know is how to go from a written equation, so a word equation, to your balanced chemical equation in the end. And the first thing is to read the equation properly. So this equation says solid iron metal reacts with oxygen gas to form solid iron 3 oxide. And I'm going to put up a few clues for you here. We're going to unveil what each of the symbols for this are as we go along. And we're going to start with solid iron metal. And when you see iron metal, your naming rules tell you iron is just elemental. So we have an Fe. When it says solid, then that solid is going to be indicated by, if you look down here, identifies solid state, so that's an S. And you put that in parentheses, so that way you know it's not an element. Some people like to put it in subscripts, sometimes you put it up high, some people italicize. It kind of depends on your author, but for this example I'll put it as a subscript down below. The next thing you see is reacts with, and down here, whenever you have more than one thing on one side, you're going to separate those two reactants or products, and this is reacting with, so it's another reactant, with a plus sign. Okay, the next thing we have in our equation is oxygen. And so when you have elemental oxygen, that's O on the periodic table, and as y'all remember from before, oxygen is a diatomic element, right? It's part of that Brinkelhoff group. So O is going to be O2 as your formula. For just oxygen, when oxygen is by itself, it's a diatomic, so it's always O2. Oxygen in this is a gas, because we're talking about something at room temperature here, obviously, around that time. So down here, gaseous state, you guessed it, is going to be a G. So we're going to put that into our equation. When it says to form, that's telling you we're now making the products. Like the reactants are done being listed. Here's what we're going to make at the end. So to form means yields. Yields are to forms, and that's with an arrow. Generally, our arrows for this are going to be drawn to the right. Later in your chemistry career, you're going to find out that there's actually some backwards process to this. You always have an equilibrium. Your reactants form products, and sometimes your products will form reactants. But for your Chem 1 course, we're just going to have our arrows to the right for now. So forming only our products. The next thing we have is iron 3 oxide. You know this 3 in Roman numerals refers to the charge on iron. So iron, Fe, has a 3+. Oxide is oxygen with a -2 charge. When you balance those charges so it equals no charge, you're going to have Fe2O3. 2 iron ions with 3 oxygen ions to balance out. This is a solid, so we're going to add that S that we've already seen. So here's our balanced chemical equation, and there's a couple things that we didn't use in this equation, so let's go over them so you have them for future reference. So if you're identifying something as the liquid state, then you're going to put an L. A lot of people like to do a little lowercase cursive L, so one of those loops, so it kind of really looks different from a 1. And if something is in a water solution, we're actually going to call that AQ for aqueous. This pulls from other languages. I know water doesn't sound like AQ, but aqueous is what we're talking about here. Okay, so here's our chemical equation. Let's really dive into this chemical equation right now. So if I drew the atoms underneath, notice that I have an iron, an oxygen, and iron 3 oxide, and that oxygen is O2 in it. So this is 1 iron, 2 oxygens, reacting to form suddenly 2 irons and 3 oxygens. That just doesn't work. So this is said to be unbalanced. The reactants I have and the products I have, they're not equal with each other. And when a chemical equation is unbalanced, it's called a skeleton equation. This just has the bare bones of what's what, but it's not balanced. It's not real life. So if we want to make it real life, we have to add these things called coefficients. So chemical equations are balanced by changing the coefficients before each compound. So that's a number that multiplies in, and it multiplies the number of everything in it. Let's bring back those animations. So I have my iron, I have my oxygen molecule, and my iron 3 oxide. Now if I want to balance my number of iron atoms first, let's say that's the one I want to do first, I know I have 2 over here and only 1, so I don't have one of these, I'm going to have 2. So that's happy. To balance my O2s, I've got 2 of them in this and 3 of them in this thing here. So I need more O2s here. Let's add it. Well, now I have 4 oxygen atoms and only 3 oxygen atoms here. Now I can't just add 1 more oxygen because I don't have that as a product. The only product I have is Fe2O3. So I have to add a full Fe2O3. So there it is, another Fe2O3. This gives me 1, 2, 3, 4, 5, 6 oxygens, so I need to add another O2. That gives me 6 oxygens, so my oxygens are balanced on each side. Now my irons aren't. I have 1, 2, 3, 4, and only 1, 2. So I need to add 3rd and 4th irons. So now I do my coefficients. So the coefficient tells you how many of each thing that's mentioned in your skeleton equation. So my skeleton equation here, it has iron in it. How many irons do I need to balance? Well, 1, 2, 3, 4. So 4 is the number I put in front of iron. Now this says I have 4 of my iron. It doesn't relate to anything else in the equation. How many O2s do I have? Well, I have 1, 2, 3. So I have 3 O2s. Now, if you're trying to count the total number of atoms of oxygen, because I'm not going to necessarily have O2 in my product, like here we have O3 as part of my product, then I'm going to have to multiply. So every molecule here has 2 oxygen atoms. So when I take my coefficient 3, multiply it by a subscript of that element, that tells you how many atoms of that element. 3 times 2 is 6, and notice I have a total of 6 atoms. How about over here? How many Fe2O3s? Well, I have 1, 2, so I get a 2 as my coefficient. If I wanted to count the total number of iron atoms, iron is Fe. If I hadn't drawn these down here, I could say, well, I have 2 times my subscript of 2, that's 4. How many oxygens? Well, I take my coefficient 2 and I multiply it by the subscript 3, 6. So here's my balanced chemical equation. There's a couple rules for balancing because I'm going to show you a shortcut besides drawing out all the atoms. So first, you only change the coefficients before every species or every compound. So you never, ever, ever change the subscript. Those are the numbers written down below. You can only tell how many of each molecule, and that's what you do with your coefficients. Also, you want to balance each element one at a time. Don't try and do too many things at once. Just take it slowly, one element at a time. Anything that's in elemental form, so last time we had both iron and oxygen in our reactants in elemental form, but sometimes you'll have just one. Save that till the end because it's easy to wrap up with that. Our second example going forward with the shortcut, you'll see what I mean by that. Sometimes you might make a mistake and over-add elements or over-add compounds. So at the end, just make sure all your coefficients are simplified. And what I mean by that is it's the smallest whole number ratio. So if all of your coefficients are divisible by 2, for example, then you've done too much and you want to go ahead and reduce it. If there's only one of a compound, don't use a coefficient. So you don't have to write a 1, it's just understood. This is one of the demoniac science attack sort of things. If a polyatomic ion is the same at the beginning and at the end of your equation, sometimes it's easy to think about your polyatomic ion, say if you have a carbonate at the beginning and at the end, as its own element. I know it's not an element, don't worry, but it's just easier than breaking it up into the carbon and oxygen sometimes. Another thing that sometimes helps is if your water is breaking up so that a hydrogen's leaving it and then you have a hydroxide in the other side of the equation. So instead of thinking of it as H2O, sometimes you might want to treat it as a hydrogen and then a hydroxide, there's that polyatomic ion, and think of them as two different things because the hydrogen might leave and the oxygen stays together and it just makes your balancing a lot easier. All right, so let's do this equation. This is a simple one, and I'm going to show you the shortcut that I like to use. So this is hydrogen and bromine, and they're reacting to form hydrobromic acid, HBr. Remember that hydrogen, when it's by itself, that's a diatomic element. That's why it has the 2. And bromine as well, diatomic element. These are both part of those Brinkelhoff guys. So whenever I have something to balance, I'm going to draw this chart. And the first thing I want to do is draw a line that separates my reactants from products, because those are the things you want to balance. The next thing I want to do is say what elements do I have present and go ahead and write that on the far left side. So I have hydrogen and I have bromine. And I've made spaces for my reactants and my products, and in here I'm going to tally things up. So I'm going to separate my hydrogen and give a nice definition for my bromine. And I'm going to count up how many atoms of each do I have on each side. So if I look at hydrogen on my reactant side, I have 2. So list 2. How many bromines do I have just over here on my bromine side? And that's 2. On my product side, I have 1 hydrogen, 1 bromine. So you can see right away that neither element is balanced. Now, since both hydrogen and bromine are in its elemental form, I don't have a precedence of which one to go for first. So I'm just going to go for hydrogen. Let's fix hydrogen. What coefficient do I need to balance? Well, which side do I need more of? And that's probably where I'm going to start. I need more of my products. So what number up here would multiply to my 1? Remember, you have a 1 understood to give you 2 to match. And I would give it a 2. That's going to change my hydrogen. Instead of having 1, I actually have 2 because I have 2 of this whole molecule, and each molecule has 1 hydrogen. So in my HBr, I have 2 of them. Here's a hydrogen and here's a hydrogen. This is also going to affect your bromine on the product side. Notice this 2 doesn't just affect hydrogen, it affects the bromine as well. So that makes that 2, and I'm balanced. Here is my balanced chemical equation, or here it is written nicely at the bottom. Alright, so this equation is a little more complicated because I have 3 elements and they're doing quite a few things. So I'm going to draw my chart. And what elements do I have? Well, just go through it. I've got iron, sulfur, and oxygen. Alright, how many of each? So first start with my reactants. So that's going to be the left-hand side of the equation. So that way. I've got 1 iron. How many sulfurs? I've got 2 sulfurs. And how many oxygens? I've got 2. Now let's go to the product side. How many irons do I have? And make sure you keep track of putting the right thing in the right box over here, because generally you pull the order from the reactants and it might be a different order in the products. So iron, I've got 2. The next thing is sulfur, and that's exactly what I mean. See how the order would be sulfur, but the next element is oxygen? Just sometimes throws people off. So go over here, sulfur is where you see sulfur, no subscripts, that means 1. How many oxygens? This is talking about the total oxygens in the whole thing, in the products. So I have 3 here and 2 here. So this is actually a 5. And you can tell this isn't balanced. One of my rules is if something's in the elemental state, you always want to save that till the end. What do you see here? Reactants or products that's in the elemental state. Did you guess oxygen? Because if you did, you got it right. Look at oxygen. Right here in the reactants, it's not bonded to anything else, so we're going to save that to the end. I'm going to fix iron and sulfur first, because oxygen I can just make work in the end. I'll show you what I mean. Let's go ahead and start with iron, just because it's the top one mentioned. So I've got 1 over here, but 2 over here. So that means I need to change and put a 2 here. This will change iron, but it'll also change sulfur. Let's first talk about how it changes iron. If I have 2 FeS2s, each one has 1 iron, so now I have 2. This also changes sulfur, because each FeS2 has 2 sulfurs. Now I have 2 of them. So instead of having 2, it's 2 times 2, or 4. Okay, iron's good. Let's look at sulfur. What side do I need more sulfur on? Reactants or products? Products. So I need a coefficient here to put in front that'll multiply in so that this 1 in sulfur ends up totaling 4. So what times this 1, because I can't change my subscript, gives me 4? A 4. So that'll change my sulfur, so that is all fixed. But this 4 as a coefficient doesn't just affect the sulfur, it also affects oxygen. So now, from sulfur dioxide, I have 4 of them, so that's 8 oxygens. I still have 3 over here. So my total number of oxygens is no longer 5, it's 3 plus 4 times 2, 8. So that gives me 11. Okay, now remember I said we can easily wrap this up at the end. I need some number over here that multiplies by 2 and gives me 11. Now, there isn't a very clear number here, and I'm going to do something that's kind of wonky chemistry, and I'm going to give this a 5.5. 5.5 times 2 does give you 11, so that works. But you've never seen a decimal in your coefficient before because you can't have that. So this isn't a whole number ratio. I'm going to need to multiply every single one of these to keep the ratio the same, but to make 5.5 now a whole number. What number multiplies by 5.5 to give you a whole number? It's going to be 2. So see how I have a 2 outside? That's going to distribute into everything and multiply in. So instead of my 2 coefficient for this FES2, it's going to be 2 times that. So this turns into a 4. My 5.5, that was what I was trying to fix. That's now also multiplied by 2, turns into 11. Here, you don't see anything, but if you don't see anything, you know that's a 1, so that turns into 2. And my last one, 4, when that gets multiplied by 2, that becomes 8. Here's my balanced chemical equation. So my coefficients are 4, 11, 2, and 8. If you have any questions on this one, be sure to ask a teacher. Okay, here are some practice problems right up there. You're going to work them out on your own. If you get stuck on any, be sure you see someone for help. We're going to come back in a minute with the answers, so you have to freeze your computer screen. Really freeze it. You know who I'm talking to. Okay, so here are the answers to the practice problems. If you got any of them wrong, make sure you talk to someone and figure out what you did wrong before moving on. Okay, best of luck balancing chemical equations.